Hey folks, welcome back to Advent of Code in F Sharp, day 19. As always, a bit of a delay, still renovating my house, and there's not enough hours in a day. But today will be actually a live code. I have not taken a look at day 19 yet. I have no idea what we're going to dive into, so let's take a look. Yesterday we did lava pool sizing. Today we have a plenty. The elves of Gear Island are thankful for your help and sent you on your way. They even have a hang glider that someone stole from Desert Island. This is Tears of the Kingdom again. Since you're already going that direction, would help them a lot if you would use it to get down there and return it to them. Cool. As you reach the bottom of the relentless avalanche of machine parts, you discover that they are already forming a formidable heap. Don't worry though, a group of elves is already here organizing the parts and they have a system trademark. To start, each part is rated in each of 4 categories. And extremely cool looking, musical, it makes a noise when you hit it, aerodynamic or shiny. Okay, then each part is sent through a series of workflows that will ultimately accept or reject the part. Each workflow has a name and contains a list of rules. Each rule specifies a condition and where to send the part if the condition is true. Oof, this is some dense problem text. The first rule that matches the part being considered is applied immediately, and the part moves on to the destination described by the rule. The last rule is a catch-all, has no condition, and always applies if reached. Cool. Consider the workflow. And then we see some very cryptic things. This workflow is named EX, okay, and contains 4 rules. Is this the day we are going to dive into parser combinator libraries? I think so. I feel like we have not used the parser combinator to do some intensive parsing. Maybe today is a good day to explore that one a bit. Anyway, this workflow is named EX and contains 4 rules. If workflow EX were considering a specific part, it would perform the following steps in order. Checks the first rule. If the parts X, which is extremely cool looking category, if it's more than 10, set the part to the workflow named 1. Okay, so that's how you interpret these rules. Otherwise, if M is less than 20, send it to 2. There we go. And we have R's and A's. So rule A30R, if the part's A is more than 30, the part is rejected. So big R means immediately reject. And rule A is a catch-all that has no conditions, immediately accept. That's some interesting parsing going on, but it's not recursive, right? Yeah, we could do with string splitting or regular expressions just fine, I think. Once my parsing gets recursively, then it gets tricky. Okay, so maybe let's not dive into... Yeah. Forget everything. I suck at regular expressions, so let's try using a parser combinator library. Okay, but I get the example. System works, but it's not keeping up with a torrent of weird metal shapes. Okay, so it works, it's too slow. We have to help using programming. Ta-da! Workflows are listed first, followed by a blank line, then the ratings of the parts the elves would like you to sort. All parts begin in the workflow named in. Okay, so there's a direction. Okay, and those flow through all the workflows until they reach... Oh yeah, and we have to end up with a final R and A, reject or accept. So there's an end state, and it's just workflow until we reach one of those. Woof, that's an interesting problem. Not too hard, not too easy. I like it. Or at least what I see here. Let's see, take a look at our... maybe let's take a look at what they do in the example. So they accept 3 parts. Adding up X, M, A, and S rating for each of the accepted parts gives you whatever. Adding all of the ratings for all of the accepted parts gives a sum total. Not too tricky. Whoa. So parsing won't be the hardest part today, I see. There's no recursion in there, but there's a lot of rules, a lot of workflows. Let's first dump my input on disk. Sorry, we are at day 19, not day 18. So let's prepare a new day. There we go. And let's dump our input somewhere. Why is my input not copy pasting? Oh, what the hell? Okay, Control V is broken. That's great. Computers, I don't know. Never mind. So we can read our input. I also want to grab the example as always. That's always a good idea to start with. This sounds like the example. Yeah. So, big question. Are we going to grab parser combinators? They are not essential for today. But they're fun to work with. Nah. Let's grab for the power tools when we actually need power tools. Yeah, let's do that. So we need to be able to parse workflows, and we need to be able to parse, what were the things called again? Parts. So let's start by parsing parts and workflows. Parts are the easy part, so let's warm up by parsing parts. And so we have our example. Let's not split on new lines. No, let's not split on new lines. Let's just take the string as is and split ourselves so we can easily find the two chunks in there. That is what is that? 2 new lines? No? What is this? 3 new lines? 4? Oh, there's some tabs in there. Yeah, there's some tabs in there. Let's not put some tabs in there. There we go. Then I think 2 lines were the actual thing we're looking for. Oof, my sound is loud. Let me work on my volume just a sec. And now my Christmas music is gone. I don't know what's happening sound-wise, so... all kinds of weird things are happening, sorry. But the audio levels seem to check out now, so I'm gonna not touch them. Maybe I'm gonna touch my Christmas music a bit. There we go. Okay, sorry, I digress. Now we have... do we have our 2 chunks? No? Why the hell am I not able to parse? Hello? Is it RN? Is that the problem? What in the world? Oh. No, that can be the problem. What the hell? Why can't I split this thing on new line? Let's try splitting it on one single new line. Okay, that works. That is good. Now split on 2. Why does that not work? Is there something in here? Oh my god, there was a space in there. No. There were 3 spaces in there. I love it. Okay, now we have 2 chunks. I have learned from experience that if I do this and I read from a file, it's not the same. So I'm gonna do that immediately so I don't shoot myself in the foot. I'm gonna read all the text in the file. So I have one long string as well. And then I'm gonna try the same thing. That will probably not work. There we go. So my hack is to just replace all carriage return new lines by single new lines. So my example and the input are exactly the same. And then I should have 2 chunks. There we go. So this works. Let's destructure. So we have our workflows and our parts in these 2 splits. And we don't need to do length, that's true. There we go. So we have our 2 chunks. And now we can split those. So parts is the easy one. Let's do that. Let's split on new line as well to get our individual part strings. And let's build a list out of the array, and let's list map. I just like working with lisps also, but that's for another day. So let's parse a part. And we're wishful thinking again. We don't have this function defined, so let's define it. Part is a string as input here, and it gives us something representing a part. Let's test drive this. So we have a part here, and let's now parse it. What would a parsed part look like? We need a type, I'm thinking, so let's introduce a type. It has the 4 categories, and those categories they don't change, right? Do we see them changing for part 2? No. So we're just gonna make a record type containing an X value. Is integer the correct range for what we want? Yeah, we're not adding, multiplying, we're just comparing. So integer is great. Cool, cool, cool. And we have M, A, and S. Oh, it's Xmas. I love these puzzles. Can I do them in lowercase? Well, maybe that's not idiomatic, but that's more akin to the problem description. So I'm gonna sin against the formatting gods and make my Xmas record lowercase. There we go. So layout. Let's have our parser return part types. What do we need to do? Let's not make it too difficult. Let's just split on. Let's substring first. So 1, 2, whatever. I don't know. Let's see here. -2 apparently. Yeah, and then split on comma. So yeah, starting to maybe think about that parser combinator again, but okay, we're getting there. And then we have xmas. So I'm gonna destructure again. XMA, what? MAS. Sometimes autocomplete tries too hard. Cool. Let's have the compiler not complain too much. There we go. So we have our Xmas parts. And then we can just split all those on the equals, or just skip the first 2 and parse to an integer. Yeah. So I'm gonna write a helper function, parse int, whatever, token, which is a string, and it will just take the substring from 0, 1, 2 to the end. Let's make sure this works. Parse int for x. It does not. Index and length. Oh, it's length. It's length. It's not the final index. Okay. How much? Okay. this is crashing for a different problem, probably formatting. Oh my god, what's happening here? I just want to skip. I just want to skip, Jesus Christ. Wait. Let's just do x minus 3. Let's take a look at what's happening here. 78. What was x again? 787. So we need one more. So why is this working, or was it not working 1 second ago? But this is correct. Then we parse to an integer, and then instead of hacking with this x, let's use the actual argument t. There we go. And now we can parse x and mans, so we can build our part. X is parsed x part, and we do this for all 4 categories. X mas. There we go. So this was parsing the easy part, parsing our parts. Let's parse this example and put it in a test. Parse part. This one should give us something. It gives us something and it looks correct. So I can copy paste. I verified it. There we go. I wish I could have let my auto formatter work here, but okay, this is good enough. We have a parse part that might work. Let's see if we can parse all parts of the example. Yeah, we have parts. So we have parts. Now let's take a look at workflows. We already have parts. Let's call those unparsed things raw, and the parsed one parts. That's a very tricky thing to say. The parsed part. I'm not even gonna bother. Okay, workflows. Workflows is a bit more complex. It has a name and it has a sequence of things. Sequence of things, that sounds like or recursive string splitting thing, or regular expression, or parser combinator. Let's do recursive regular expression. Let's do regular expression. Can you match on? Can you do this with a regular expression, like a list of things? Capturing numbered text list. Whoa. Yeah, it looks like you can capture on iterations. Let's play around with that for a second. So I'm going to do 1, 2, 3. I want to capture the 1 and the 2 and the 3 out of this using a regular expression. There we go. So this is a regular expression that should match. Should match line, or let's get rid of line. We don't need it. We're just playing around. So what does this give me? It gives me the entire matched string, right? Cool. Success true, value match. Okay. So now if we want to say grab me, the comma. Comma is in there as a separator. It's not there at the end. We could hack and just plug it in there. So we could say this, this, this. How do you define a capture group again? And then this entire thing is repeated, something like this. Yeah, we have multiple groups. the groups don't look correct. I see 1, 2, 3, 1, 2, 3. I was expecting 1, 2, and 3. I want to capture this, right? How do you define a... How do you name a capture group again? Oh, it's been, what, 2 weeks since I last used the regex? Yeah, you're right. I can just take a look-see at how I did it. There we go. So you just do this to name a group, and then you say groups, key, value. Yeah, okay. It's coming back to me. So I want to capture whatever's in here. So that's a rule. So this should capture our rules in just a second. So let's do something with our match here. Is it groups or captures? I forgot. Groups. And it's groups rule. There we go. Length 5. That looks like something promising. Sorry, how do I grab every element? Oh, dot value. Sorry. This is what I want. Dot value. Nope. How do I iterate over these things? What's a capture collection? Jesus. Okay, I can just do this. So that's 1, 2, 3. Don't want. That's crashing. How can the length be 5? Oh, the length is 5. It's a string. Ah, that's not what I want. Jesus. Can you not do what I'm trying to do with a regex? This is me, 10 years of experience. Struggling with regexes. Maarten, if you're watching this, I'm thinking about you. He was my go-to regular expression colleague. Or still is, actually. Sorry. Still is. My internet is not... Okay, there we go. You know what? Screw this. Regexes are out of the window. So that's back to recursive function using string splitting or parser combinator library. Let's see how far string splitting gets me. So let's grab an example. What looks like the most complicated one? We have A's, we have R's, so I would like one with an A and an R in. Forwarding to another one is also pretty cool. This one looks interesting. Yeah, this one looks interesting. So let's parse workflows. Again, I'm gonna play around with an example until it's working, and then we can encode that example in a test. So there's a... we need a workflow name because we need to pipe from one workflow to the next. So let's split already on... Yeah, let's not use regexes ever. Let's ban them. So let's split on this. And that is the name. Oh, I'm already regretting my decision not to use parser combinators, actually. So let's rework this after we get it working. This is really unreadable, messy stuff. So we have QQZ and we have whatever, remainder. For remainder, we can skip the last thing. We don't need that closing mustache. Is this how you do it? Yeah, that's how I do it. Cool. So we have the remainder, and that we can split on comma. And what are the things in the workflow? Do they have a name? Rules. So let's split on comma, and then we have rules. Those look like rules indeed, and then we can parse every rule individually. And then we can rules array.map parse rule array to list, and we have lists again. And now we only need to think about the sub problem, which is parse rule, and that returns a parse rule. What the hell happened with my auto formatter? Why is everything red all of a sudden? Do I need to give this a hint? Type hint. Yeah, that was a problem. Cool. So yeah, we broke the problem down. Now we have to parse rules, and then we have to think about what we want our parse rules to look like. So I see a catch-all thing, so that has no condition, and some have conditions, and they have an output or a next workflow, or accept reject. So we have an output. That's a word I used. So let's call that a, or let's call that, yeah, I don't like using result because result is a very weighted term that has a lot of meaning in functional languages. So I'm going to call this output, and it's either accept or reject or no, let's keep it like that. So we have an outcome. That's the final outcome. And we have an output, which is final output, which is an outcome. Or we have a next rule, which is just a string. So that's the output of a rule. And then a rule itself is a record containing criteria. Let's also encode those criteria, which is X or M or A or S. Oh, can I not use lowercase? I did not know that. So we have a criteria, criterion. Yeah, let's use criterion. We have an operator, which is, what can all the operators be? Bigger, less than, or greater than? Are those the only ones? Oh, I was thinking, oh no, we have equals, but equals is only in the parts. So yeah, we have less than and greater than. Cool. I'm just gonna also define a union for that. Less than or greater than. So we have an operator in our rule, which is an operator. And then we have a value to compare against. I don't know if comparand is a valid word. A thing to which something is compared. Let's go with comparand. Yeah, sure. So we have criterion, operator, comparand, and an outcome. An output, sorry. So I'm doing a lot of type-driven development here. I'm just taking a look at what I want. And now we can figure out how to get there when parsing a rule. So in order to have our compiler help us, we want a rule and not a unit here. So let's have the compiler not crash. How do we fill in this? Let's start with the easy ones. We have rules that are just something, just outputs. Yeah, we have rules that are just outputs where we don't have a check. So let's also encode that thingy or that insight. We have a check, which is this part of the rule, the left-hand side of the rule, say. Come on. Okay. And then we have a rule that may or may not have a check. So that sounds like or a union type or an option. Or you know what, union type is maybe even cooler. So we have a rule that is a checked rule that has a check. So that is check and output. Or a direct outcome. Output, sorry. So our rules are even smarter than I initially thought. This will get us there, yeah. So the direct outputs are easy. We can start with those. Let's try to parse rule R. That should give us the direct output containing outcome of accept. There we go. So this R should parse into this crazy output outcome accept thing. Okay. Yeah, that'll work. Sorry, we're crashing on line 65. Why are we crashing? Oh, because we have fail with. Makes sense. Yeah, so how do we do this? This is easy. That's a direct match on rule. If it's just R, then we have the easy case. This is wrong, it's a refuse, reject, sorry. So this is the R case. This should pass our test. Yep. And then we have A, which is an automatic accept. We can always write a test for that one as well. Should also work. Cool. But that was the easy one. Do they always end with an accept or a reject? Sorry. Or do they sometimes end with... Oh, there's an example that just defaults to something else. So if it's something else that does not contain criteria, it's exactly the same, but instead of an outcome, it's an output. So that's the catch-all, is it not? Next rule, sorry. It should be next rule. So this is the base case, and this is the case where we do rule condition check stuff. Yeah, so I like condition. I just said the word, sounds better than check. So it's a condition, and it's a condition rule or a direct output rule. Yeah, that sounds better. So how do we figure out whether or not we have a condition? If there's a semicolon in there, that's a bit hacky, but it works. So when rule contains a comma, no, colon, then we have a parse condition. And otherwise we have a catch-all defaults to output. And we can put that one first. It's not really, doesn't really matter where we put it. So parse condition, rule, string, so a nested function. Okay, so in this case we made the problem smaller again, so we know very much that this is a rule containing a condition. We don't have to worry about all the other edge cases. Problem is a bit smaller. So how would this look like? Come on. Okay, so let's have this return rule so compiler can help us. So that's one of these cases. Again, we can split on stuff. So we have the condition part and the output part, which is splitting on the colon. And the input is rule, not split. That happens when I talk and type at the same time. So yeah, let's take an example. Let's put it in there so we can play around with it. Yeah, we have a condition and an output. Output can again be A, R, and output, right? So I think parse output is something we also need because we need it multiple times. And outputs can be any of these three. So this is actually parse output. So this pattern match is becoming less and less interesting. And this can become a function pattern match, a bit shorter, easier to read, or at least if you know the shorthand. So yeah, that's parsing outputs. That's parsing outputs. I don't like this pattern match anymore, so I'm gonna do plain old if statements. If there's only one arm or two arms, I find those a bit more readable. It's a matter of taste, actually. There we go. So we reworked stuff as we were going along. Now we can take a look at parsing rules, and we have outputs. We can parse outputs. Sorry, just need to send that one to the REPL for a second. Next rule QS, that sounds correct. And now we just need to parse the condition. Again, I'm hoping this function exists, and it doesn't yet, so we introduce it. Parse condition, yet another function. And that's the, as you see, my helper functions my parsers at least, look the same as my types. Or I'm not gonna dive as deep as criterion and operator maybe, but the decomposition happened when I was thinking about the types. And now that I'm programming, it kind of follows along. So that's a cool symmetry right there. Anyway, once we have conditions and outputs, we can parse the entire rule. So we're almost there. Let's take a look at parsing conditions, which is here. And a condition is something like this, right? So again, we're not done playing around. Let's call it C, so I can send it to the REPL without problems. What do we want? We want to... Yeah, we kind of know that there's only two operators, right? Is there an easier way to... Yeah, with regular expressions, we could get there. Could you split on more than one thing? I mean, what's the split overload? It's a param array with a char array. Yeah, that could work. What happens if I do this? It gives us exactly what we want, but then we forget about the separator. I kind of would want to know which separator. Let's just keep it simple. So if my condition contains this, then I know a lot. So let's do it this way. So we're going let's keep it simple route today, as you can see. That's a lot of string splitting instead of grabbing for fancy tools. Kind of like it, actually, kind of like it. So if we could, we have the less than operator, then we know a lot. We can split on less than. And then we have S and 277. So that's all we need, actually. Cool. So that is the comparand and the, what was the first thing called of our condition? Criterion. And then we can build the condition, which is a record type containing criterion, operator, and comparand. So criterion is yet another parser. So let's dive in. Now I'm taking big steps without testing, but it's very straightforward, so I'm not too afraid. And we can verify the end result really quickly, so I'm not too worried. This is a raw pattern match again. If it's X, we have an X. MAS. I don't think we need this union type. We won't have a lot of bugs in Xmas characters, but let's go all the way. We have a criterion. Our operator is very simple. It's less than, because we have this if statement, and then we have our comparand, sorry. We could have used operand, I guess. But yeah, let's actually use operand. Is that always a number? Yeah, it's always a number. So let's just parse the end value out of operand, not comparand. So let's rename that as well. There we go. That's the first part down. Why is it not seeing parse criterion? Because I cannot type. Crit is a string. Okay, that's true. Dang it. Oh, dear Lord. If only I knew Vim. This is where my like keyboard expertise fails me. I don't know like all the crazy, fancy, fast ways to navigate or replace multi-line things. Anyway, digressing. This is the less than case. The greater than case is very similar. Sorry, why? Okay, there we go. Ooh, I don't like what I'm seeing here. No assignment for field criteria. Is this why is this failing? Are you okay, auto formatter? Oh, I do the if. Yeah, I also need to do the let binding, the splitting. A bit of duplication, I don't mind. There we go. Or let's keep it very symmetrical, so it's super clear what we're doing here. And in the other case, we can just crash. We don't care about problems, we just want to crash with an unknown operand. There we go. What is happening? Why is this? What's the problem? No assignment for field operator. Oh, I need to. It's like a interplay with auto formatting, getting rid of those semicolons. Come on. Okay, it was just very slow. Okay, and now it formats correctly with all the tabs and the spaces. Cool. So this code is symmetrical again to what's above. Kind of like it. Very straightforward, very readable, I think. We have one fail with to do, and if that one disappears, we might have our workflow parser. So let's take a look. What does our rule parser? And then this collapses in our workflow parser. I hope. So let's take a look at fail with to do. We want a rule, and a rule is or. How do we figure out we're in the or the or? Oh yeah, this is a condition rule, so this always returns condition. Which is a tuple of a condition and output, so this should compile pretty much. Sorry, O is returning a rule? Oh yeah, that's not supposed to happen. We need to have a output. We need to have this at least. And that's output, yeah. Not a rule. Silly me. I was talking about the nice symmetry between my types and my functions. This is parse output, so that returns an output. There we go. Oh no, and if I do that, I need to define an input argument. So forget about this. Cool. So this parses a condition rule. The if expression needs to have type output. No. This has to be an output rule. So this has to become output. And let's pipe the results in there. Output does not have rule. Sorry, what was that thing saying? The type output does not match the type rule. Is it because I used the output for two things? I don't even understand what's happening. Let's put some parentheses in because I think maybe the problem is... How is output not a rule? What the... Oh, no. I don't see what's wrong here. Rule dot output should actually work. Parse rule returns... Oh, that's not correct. Parse rule needs to return rule. This nesting functions is... I confused myself using nested functions. That's impressive. Yeah. Okay, but now it works. We can get rid of those small things and we can grab the entire workflow and try to parse the entire workflow. So this is another of our tests, which parses rules, which is like detail. I'm just gonna try the entire workflow here. So let's call this function parse workflow. And let's send everything to the REPL and try it out. Ooh, that worked better than expected. So we have a list of rules. No. No, so we're not done, sorry. We have a list of rules. And if we have a list of rules and a name, then we have a workflow. And the rules have to be sorted. So it has to be a sorted thing. So a list, for example. So workflow has a name, which is a string. And it has a set of rules, which is a sorted list of rules. And it's a type, so no equality sign. There we go. And we're almost done. Just need to construct this type. There we go. What now? Oh. I've been typing too long. There we go. So I'm making silly mistakes. That's not a good sign. We use the name, we use the remainder to get rules. Yeah, okay. I think we can now parse workflows. So we have a rule called QQZ with two, or a workflow QQZ with two rules. No, three rules, that's correct. S greater than 277. Next rule is QS. Otherwise, M less than 1801. Yes, then we go to HDJ, and otherwise we directly reject. That looks correct. Cool. So let's put the test around it. Oh God, I got rid of my test data. Why? There we go. Parse workflow this should be that. And we again verified it by hand. And I'm pretty comfortable with what I see, so I'm gonna grab it. And that should equal this. And I hope my auto formatter will help us here. I do not want to fiddle around with formatting. Oh, shoot. No, it's okay. Let's have these tab things line up. Let's indent this bit more. Oh, come on. I think we're almost there. There we go. Yes? No? Maybe? Yes. Cool. So let's run everything again. Yeah, our test is green. We can parse that single workflow at least. So we can parse parts. We can parse workflows. So parsing was actually the hard part for today, for me at least. Now I'm wondering, would using a parser combinator library have sped this up? So that's a nice challenge for me after we solve today's puzzle. So sorry, we need to, let's focus on the task at hand and let's then start thinking about the future. So we need to split just as we did with the parts. So we have individual lines and then we can do this, but with our workflow parser instead of our part parser. Part parser, part parser, part parser. That's not easy. Okay, there we go. So we have workflows. Cool. We're going good. I'm gonna run it on our input just to make sure that we capture the full range of inputs. Better now than later. Yeah, no crashes, we're good. I think we can parse. Did not even verify a single line of the input. So we have parts and workflows. What were we supposed to do? Have every part go through our workflows, and we start at the workflow named in, right? And then we just go until we find a final outcome for each of those parts. So we are filtering our parts to get only the accepts. Let's take a smaller step and let's just map the final outcome of every part. So we have our parts and we need to enrich them with data. That sounds like a map. That takes the part and then we apply the workflows to the part. And we also remember the part because we need to count, we need to calculate whatever it was, the part score, the part something, ratings, yeah. So made the problem smaller again. Now we can think about the apply function. Apply takes workflows and a part, and it returns an outcome. Let's reject everything just for now. So that should compile. Yeah, and we're rejecting everything. Great. So how do we apply workflows on part? We start with workflow in. I'm gonna grab the first part and let's play around with it. So the first part is this one. Oh, one tab more. There we go. So we have a part and we have our workflows. Let's play around with those. Let's find the first rule or first workflow. And now I'm thinking I kind of want my workflows to be a lookup table, mapping workflow names to the workflow. So let's make workflows a map. So we can map our workflows to workflow.name and the workflow itself. And if we put that in a map, we have our lookup table right there, which maps workflow name to the workflow itself. Cool. Yeah. So let's find in now. That is workflows map.find in. Yeah. And then we apply workflow. So I'm already thinking about, we have to call this with different workflows. I'm just going to do apply workflow, given a flow and a part. And maybe even recursively. I'm not sure where we're going to put the recursion. Let's not worry about that. Let's take a smaller step. So we have our workflow and we want to apply it. Yeah, so we're going to need an apply workflow. Sorry for this confusion. This happens when I code for 55 minutes straight. My brain is not good at long sessions. And we need some kind of outcome, right? Some kind of output, sorry. So an example to have the compiler shut up is apply the next rule, please. So this is not recursively calling, it's just applying a single workflow for now. And this has type workflow. This is type part. When things get a bit more complicated and we're at line 130 of scripts, I kind of like using types in my function signatures to not confuse future me and future you. So we can pattern match our workflow and define our application logic like that. Yeah, why not? What are the different cases a workflow can be? Oh, come on. If things don't compile, I don't even get IntelliSense. What is this? Where is did my IntelliSense just crash? I hover and I see nothing. Tool support anno 2024, ladies and gentlemen. This is amazing. Oh, now it works. Why doesn't it work for my function here? There's no compiler errors. Interesting. So workflow is a record type. That's not what I'm thinking about. Oh yes, we have to match. Yeah. Sorry. So this is just a list of rules. Sorry. So we have to apply the first rule, and the last rule is always a catch-all. It sounds a bit like pattern matching, but it's with dynamic data, so we can't actually use a pattern match. So we can do what's the correct thing here? Let's just write a recursive function ourselves. So apply rules, given the rules on a part. So we're diving another level deeper. Let's keep that as an inner function because I don't think I want to check that one by itself. We don't need a part. We can use a part of the outer. No, I've written a lot of bugs by using arguments of my outer function. So I stopped doing that altogether. Yeah, there we go. It's a recursive function, and now we can pattern match on the rules. We could pattern match on the rules. Yeah, let's pattern match on the rules. And we can put a guard in there when the rule applies to the part. Or let's not do it this way. So grab the first rule. Actually, there will always be a rule in there. So let's just do first rule is rules, or let's call it next rule. Rules list head. So let's take the next rule. If next, or if next rule applies to the part. So we also need to apply it and not only check whether or not it applies, right? So I'm going to call the result apply next rule to part. So that's another function. We don't know what to do there. And if that applies, we have a hit. So if how will we return, like, this is the result and no, it didn't apply, or yes, it applies. Options. I'm gonna use an option for that. So match R with some result. So some output. That's great. That's the output we want. And otherwise, we recursively call apply rules with the remainder of the rules, which is rules tail. Can you do uncons? No. You can't uncons a list apparently. So that's applying the rules recursively with the rest of the rules on the original part. So now we just need to think about applying a single rule to a part, potentially applying a rule to a single part in this apply function. Yeah, let's pattern match on rule now. I think we can finally pattern match on rule. I can't navigate to rule. And here I can. This is crazy. So it's either a condition or a direct output. Cool. So let's pattern match on rule. And if we have a direct output, we always apply, so we return the positive case. Otherwise, we have condition, which is a condition and an output. So it's CO. So if condition applies to part, then output, otherwise condition did not apply. So now we can work on applies. Applies part condition. That can return a bool. Cool. We're almost there, I promise. So if a condition applies to a part, how do we check that? Condition is a record, so we can do match on the operator. So if we're less than, then... Yeah, what does that mean actually? How does that work? So the criterion is always on the left? Yeah, it's always on the left, and then we have the operator, and then we have the operand. So it's criterion, operator, operand. So we have, if we have less than, then criterion, we need to grab this right criterion out of the part. So let's do a get condition.criterion from the part. So that's the criterion. Let's grab that. Yeah. So let's crit equals this. That's another function we need to define. So let's define get. Get a criterion out of a part. That can be a pattern match or has to be a pattern match. And if we change the order, we can just do a pattern match. And that's this x, we return p.x mas. xmas s, sorry. So that gets, I can swap order of arguments. So I get the criterion out of the part, a match on the operator, and then I can verify whether the criterion is less than the operand. And for the greater than, it's the other way around. So I like to keep I don't like switching. If I see a greater than here, I want to see a greater than here. So that's why I'm swapping positions and not swapping operators. So yeah, I think we might be getting close to somewhere. And we're only 1 hour and 4 minutes in. Sheesh! We have our apply a single. Oh yeah, we're not done. We're not done. We can apply what? Oh yeah, actually it's a recursive function. It's applying rules. I think we might actually be somewhere. So what is this function again? Apply workflow. That's the one we need, yeah. So apply workflow, inflow on part. What did that return again? An output, not an outcome. So it states that our next rule should be QQZ. Now this means that the first two conditions did not match. So S is not smaller than LT, smaller than 13, 15, 51, that's correct. Oh, there's only one condition, sorry. So yeah, we default to QQZ, that is correct. Yeah, and then we can write another recursive function. So it loops over doing this exact thing what we're doing here until we reach the end state. Almost there. Almost there, I promise. So we find the relevant workflow, we apply that workflow, we take a look at the result. So that can be a direct outcome. Then we just return the outcome, or it can be an output. And then we recursively call ourselves. So let's, didn't I have an apply? I'm just gonna call that apply workflow or run workflow, starting with some kind of start flow name and a part. And we find that's starting workflow. So let's also push workflows in here. We find that one, we apply that single one, we take a look at the outcome. If it's just an output, which is outcome or next rule. So that is outcome or the next rule. So wait a second here, let's get my head straight. So we have an outcome and a next rule. If we have a direct outcome, outcome is a output. Output is a... This is not correct. Why am I getting confused? Applying a workflow, what does that return? An output. So let's encode that. An output is either an outcome or a next rule. Either an outcome or a next rule. Okay, so this is the next rule, sorry. So there's only two cases, sorry. So we have a final outcome or we have to continue recursively. Yeah, okay, makes sense. So then we can recursively we can recursively call this function, so let's do that. Let's make it tail recursive. So just pipe in the workflows. The new start is the next rule name, and the part stays the same. So actually, I'm kind of thinking workflow stays the same, part stays the same, so only the name changes. So let's change the order a bit. I always like sorting my arguments from most stable to the left to the most volatile to the right. So yeah, I think actually now, I've said it before, but now we might be getting close to getting somewhere. And we're 200 lines of F# code in. So now we can do apply, which is a basic call of run with workflows and a part and starting with the inflow. Oh my God, I think we're done. Let's try. Let's see, I have some interesting test data. I'm just not even gonna encode that in unit tests anymore. This is relevant parsing logic, or parsing the example. All the rest is type definitions, blah, 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 blah. Yeah, so all this was functions. Now we are ready to run stuff. Functions and type definitions. So let's start parsing our example. That's correct. So let's parse our parts and workflows. And if we have our parts and workflows, we can apply them. Ooh, and look at this. We have accepts and rejects. We're getting somewhere. Now let's keep all the accepted ones. So filter on second. Accepts. All the rejects we don't want. So you can do it like this, for example. So it's a bit of a dense statement, but it's basically taking the second element of this tuple and checking whether or not it's an accept. And there we go. That's all our accepts. So let's then grab all our parts themselves. And then we can calculate their rating. So we can do a rating. Oh my god. It's actually pretty cold in here. That's why my fingers are not working or not cooperating. So we have a rating function yet to go. Adding up all three parts, except adding up the X, M, A, and S rating for each of the parts gives the three parts are accepted. Adding up the X, M, A, and S rating for each of the accepted parts gives 7540 for the part with X is... Okay, so for this part, our rating is this. Yeah, so let's rate this one. That's just a part, right? We could just copy paste that and replace our commas by semicolons. In selection, please. And my selection is gone. Jesus Christ. Oh, I give up. My mouse is now even not cooperating. So yeah, back to doing it old school. There we go. So rating for this part should just sum those four up. So that's easy. Let's give it a type hint. So it's a lot of parsing and a lot of stuff, but I think it was pretty straightforward today. I'm curious about part 2. So this looks correct, right? 7540 is correct. Cool. I'm gonna encode that one as a test because it's pretty simple. Did auto formatting break shit again? I can't believe this. I can't believe this. I love auto formatting, except when I don't. What the fudge happened? Oh, it got rid of a comma. That's not what you're supposed to do. There we go. Oh, it was just getting rid of a comma that broke everything? Cool. Let's encode that test. I'm completely derailed now, thanks to that thing. Great. So we're trying to rate this part. That should be 7540, correct. There we go. Ooh, we have some ratings here. 7540, 4623, and 68951. That's correct. So we just need to sum it up. And we should have our result. $19,114. That is correct. Cool. rating is function. I'm gonna put that somewhere by my apply. Sure. This is all the parsing. So let's write a parser. Let's just wrap this in a function called parse, and it returns a tuple of the parts and the workflows. So that's a string right there. We need to help the compiler again. And then we can do parts, workflows, destructure, and call parse on our example. That should all work. Cool. Now we're getting close to being really done. I'm gonna rename this. And there we go. Just cleaning up after myself a bit. So we have something that parses, something that rates. And that's all we need, yeah. So let's run our input. We have a number, cool. And that's correct, first try. First long-winded attempt, but it was correct. Oh no, I saw a big number. Yeah, let's take a quick look-see at part 2. One of the elves comes up with a new plan. Rather than sort parts individually through all of these workflows, maybe you can figure out in advance which combinations of ratings will be accepted. So what we're doing right now is running single parts through and then filtering them on accept or reject. Now we want to figure out in advance which combinations of ratings will be accepted. Interesting. Oh, those combinations of ratings. Each of the 4 criteria ratings can have an integer value ranging from 1 to 4,000. Of all possible distinct combinations, that's 4,000 times 4,000 times 4,000 times 4,000. Your job is to figure out which ones will be accepted. In the example above, there's big-ass number, distinct combinations of ratings that will be accepted. Consider only your list of workflows. The list of part ratings that the elves wanted you to sort is no longer relevant. How many distinct combinations of ratings will be accepted? So seeing this number, running all gazillion options will probably not work. This is going to take a bit of thinking, and we're already 1 hour, 20 minutes in, so let's stop here for part 1, and I'll continue on another time for part 2. It's only a small prompt description, but this requires a bit of thinking. So, quick recap of part 1. I immediately regretted my decision of using string parsing, raw string parsing without any regular expressions or parser combinators, but that's for another time. How did we solve part 1? We literally parsed the heck out of it. We parsed our workflows, we parsed our parts, and then we wrote an algorithm that applies our workflows basically. So it was, yeah, a lot of typing. What's the interesting function to take a look at? Parsing is very tedious, but very straightforward. Maybe let's start with our apply workflows. That's the meat of the matter, right? Yeah, applying workflows for a given part is the meat of the matter. That looks up the inflow and runs that workflow recursively. So it finds that workflow, we apply it, and if we have a final outcome, which is accept or reject, we're done. Otherwise, we recursively proceed with the next rule in the chain. And applying workflow is none other than just taking a look at, hey, what do we have here? Rules, taking a look at the order of rules we can apply. So yeah, it's a very tedious problem to hammer out, but it was pretty straightforward. And for part 2, I'll have to get back on you. So this was part 1 of day 19 in an Advent of Code in F#. Hope to see you again next time. Glad for having you. Bye-bye.